Hey class, this is Mrs. Radigan with a video on the quadratic formula. Many of you probably already know the quadratic formula, and just as a refresher, here's a little video with a song to remind you the tune to remember it by.
Plus or minus the square root of b squared minus 4ac all over 2a. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a.
Something you may not have learned yet is how to use what we call the discriminant. And the discriminant is the value that you calculate that is under the radical. It helps us determine how many and what type of solutions we get when we solve a quadratic equation using the quadratic formula. So the discriminant is only the b squared minus the 4ac. If the value underneath the radical sign comes out to be a positive number that is not 0, then you always have two places where the quadratic or the parabola crosses the x-axis, and so you have two real solutions. If the number under that radical, b squared minus 4ac, is 0, that means you're adding and subtracting nothing to negative b, so there's just one place where that parabola touches the x-axis, and that's at its vertex. So when you have a discriminant of 0, you have one real solution. If the value under the radical is negative, we haven't talked about negative numbers under a radical, but those are what we call imaginary numbers, and they have no real solution. So your graph will actually not cross the x-axis. It will either float above it if it's a positive parabola, or it will float below it if it's a negative or upside down parabola. Let's go ahead and do 3 examples to help us figure out what the solutions of the quadratic formulas are and what their discriminant is. So if we start with A, the first thing we always want to identify is what are the A, the B, and the C for the equation. Now it's always important that the equation is set equal to 0. If everything is not already on one side of the equation, we want to move it over. And since it is, we're going to go ahead and set that equal to 0, and we're going to identify what our A, coefficient on x squared, B, coefficient on x, and C, the constant, are. So our A is 1, our B is 4, and our C is negative 41. And we're going to go ahead and plug these values in for A, 1 here, 4 for B there, and negative 4 for C there. So we will have x equals negative 4 plus or minus the square root of 4 squared minus 4 times 1 times negative 41, all divided by 2 times 1. And then we'll go ahead and just crunch those values. And we get negative 4 plus or minus 4 squared is 16, and negative 4 times 1 times negative 41 is actually a positive 164. Be careful when you have those two negatives to make it a positive. All divided by 2 times 1, which is 2. So this gives us negative 4 plus or minus the square root of 180 has a perfect square of 36 in it. So 36 is really the square root of 6 squared times 5, which is just 6 root 5, all over 2. And then we need to go ahead and simplify. Since every term has a 2 in it, we'll go ahead and divide all of these by 2. And we're going to get x equals negative 2 plus or minus 3 root 5 over 1, or just x equals negative 2 plus or minus 3 root 5. We could say that is really x equals negative 2 plus 3 root 5, and x equals negative 2 minus 3 root 5. So we could write it as two separate solutions. We also see, if we look under the radical here, that our value under there is 180. That's what we call the discriminant. We saw back in the notes that when the discriminant was positive, we got two real solutions. So a positive discriminant, or a positive number under the radical, gives us two real numbers. Okay, let's go ahead and try letter B. In this example, not everything is on the same side, so we're actually going to have to move the 36 to the other side. So we would get x squared minus 16x, subtract 36 from both sides, and we get minus 36 equals 0. So then we would identify our a as 1, our b as negative 16, and our c as negative 36. Then we'll go ahead and plug those values into the quadratic formula where they belong. So we would get 16 plus or minus negative 16 squared minus 4 times 1 times negative 36 all over 2 times 1. So this is 16 plus or minus, this becomes a positive 256 plus 144 all over 2. And that gives us x equals 16 plus or minus the square root of 400 divided by 2. We know the square root of 400 is 20. So we will get two values here, 16 plus 20 over 2, and 16 minus 20 over 2, which gives us 36 over 2, or 18, and negative 4 over 2, which is equal to negative 2. Again, if we go back and look at our discriminant, the value under the radical, b squared minus 4ac, is a positive 400. So if we have a positive number under the radical, we get two real solutions, which we saw when we got the 18 and the negative 2. So this means that this parabola crosses the x-axis way over here at 18 and at negative 2. So it would look something like that. Don't know how far down it goes or how wide or narrow it is, but it definitely crosses at negative 2 and 18. Okay, we'll go ahead and do example C, assuming that this is equal to 0, so we can solve it. Everything is on one side of the equation, so we don't have to move anything. So we can identify our A as 2, our B as 4, and our C as 2, and then go ahead and plug that in. So negative B, negative 4, plus or minus B squared, 4 squared, minus 4 times A, which is 2, times C, which is 2, all over 2 times A, which this time is 2. So we get x equals negative 4 plus or minus the square root of 16 minus 16 all over 4. This gives us negative 4 plus or minus the square root of 0 all over 4. So again, we can make two equations, negative 4 plus or minus. The square root of 0 is just 0. So if we were to make the two equations, negative 4 plus 0 over 4 and negative 4 minus 0 over 4, you see that all we get from that is just negative 4 over 4, or x equals negative 1. So in this example, we see that when we have a discriminant, or that value under that radical that's equal to 0, we only got one x value because these two equations gave us the same value, negative 4 plus 0 and negative 4 minus 0 both give us negative 4. And so we only get one real solution, which is x equals -1. We're going to go ahead and skip example D because we've done the type of problems that we already or that we're going to do. We'll go ahead and do something with a negative under the radical and imaginary solutions after we learn about imaginary numbers. And we're going to go ahead and talk about the theoretical derivation of the quadratic formula from the standard form ax squared plus bx plus c. I think the easiest way to learn is from this YouTube video.
What we want to do is find a solution to the equation ax squared plus bx plus c. And the technique that I'm going to use on this one, we're going to use what's called completing the square. So I'm going to group the x terms together. Plus c equals 0. And what you do is you factor the coefficient, whatever the coefficient on x squared is, we have to factor that out. So I'm going to pull an a out, and I'll be left with x squared plus, well, to make the algebra work out, I would have to turn this into b divided by a times x. Because again, if I distribute, I'll get ax squared, the a's will cancel out, I'll be left with bx. Plus c, he's just chilling out. We're not doing anything with it, okay? We didn't factor anything out. Now, completing the square says we take, so we throw some extra stuff inside of here. And it says what we do is we take 1/2 of whatever the number in front of x is. So that's 1/2 of b over a. Well, that's just b over 2a. And then it says we square that. That means we have to square the top and square the bottom. If you square the top, you get b squared. If you square the bottom, you'll get 4a squared. So that's the new thing that we throw in there, is b squared over 4a squared. I've got to be a little more careful here. I've still got my plus c hanging out, but if you distribute this out, I'll get my ax squared, I'll get my bx term, my plus c is still there. But I'm going to get something extra when I multiply my a times the b squared plus, or excuse me, the a times the b squared over 4a squared. If I multiply this out, I'll be left with b squared on top. One of the a's will cancel out, so I'll just have 4a on the other part. So really I added the number b squared over 4a to the left side. To keep things even, I'm going to have to add b squared over 4a to the other side as well. The point of completing the square is that now you can write the stuff in parentheses as a perfect square. And whatever half of the middle term is, that's how this will factor out. So you can multiply out x plus b over 2a times x plus b over 2a. We will get this stuff back in parentheses, x squared plus b over ax plus b squared over 4a squared. The other thing I'm going to do is I've got this b squared over 4a. I'm going to go ahead and subtract this c term from both sides. Next thing I'm going to do to get rid of the a is I'm going to divide both sides by a. I'll get x plus b over 2a squared equals, I'll get b squared over 4a squared minus c over a on the right-hand side. What I'm going to do on the right-hand side now is just get common denominators and just to clean it up a little bit. So this is x plus b over 2a squared. That's what's on the left-hand side still. On the right-hand side, if I get common denominators, I would have to multiply top and bottom of the c over a. I would have to multiply the top by 4a and the bottom by 4a so that I get my 4a squared term. Common denominator of 4a squared. And then on top I would have b squared minus c times 4 times a, but I can write that as 4ac. For the square, we have to take the square root of both sides. Okay, so on the left side, we'll just be left with x plus b over 2a. On the right side, remember if you take a square root, you get positive and negative. So we'll get the square root of the top, b squared minus 4ac. But also remember, if you have a square root, a big square root, you can take the square root of the top, which we did, over the square root of the bottom. Well, if you take the square root of the bottom, you'll just be left with 2a. To move this b over 2a to the other side, so we can actually